The following figure show a brick wall of a section of a house, the temperature outside the wall. This will be the system in Malaysia, 33 degrees and 28. Now, find the rate of heat transfer per area through the wall. So, you got higher minus lower over the thickness of the wall. Now you want the heat transfer per area is like that. Okay. Now you know this, they give you this. So all together you get this. Now, number two, the temperature of the air outside the house must be higher than 33. Okay, explain why. Of course, it has to be higher than 33. If not, the heat cannot flow. So, the temperature here is 33, but the temperature here is greater than 33. You know why? So the heat can flow. The heat need a difference in temperature to flow. So this is greater than 33. So heat will flow from the air to the wall and then through the wall. Okay. So the answer is, again, because of heat flow from the air outside the house to the outer wall, okay, and through the wall. If there's no difference in temperature, the heat cannot flow, okay? So the temperature outside must be higher than 33. So these are things that you should think about. Deduce the rate of heat transfer between the air outside and the outer surface of the wall. It must be the same as this. If not, the temperature will not be constant. When the temperature is constant, we call it steady state. Now, when we use this formula, steady state must be achieved. So the temperature at every surface doesn't change anymore, okay? In the beginning, steady state won't happen until the heat flow is constant, okay? So because of that, the answer is also 30 watt per meter square, okay? So there's a rate of heat transfer being air outside. Here, so here, 30 watt per meter square. Here, 30 watt per meter square. Here, 30 watt per meter square. Okay. So they might ask this question in a different way. Okay. So this question is a good question for revision. Now this kind of wall, Malaysia, we don't do this because it's expensive. Even country overseas, those days, they would make this kind of wall because it's very good for insulation. But it's expensive. So nowadays also, I don't think they have this kind of wall. Okay. Now, alternate structure of wall is a layer 10 centimeter. Layer of air 10 centimeter thick is suggested as shown in following figure. The thermal conductivity of air. You notice that the air has very low thermal conductivity, showing that it's actually a very poor conductor of heat. If you consider conduction only, okay? So, see, brick is a better conductor. Find the heat transfer per unit area through this new wall. So again, you do this. Now use the formula that you learned. Is 33, is 28. Don't need to find in between temperature, just take this. Okay, and then 0.10. K brick 2 times because of 2 layers plus 0.10 over K air. Okay. Now you get this, rearrange. And now you get 0.94 watt per meter square. See, just now 30 watt per meter square, now it's 0.94. That means the insulation has improved a lot. Okay. So your house is cooler than outside, your house will remain cooler for a longer time, much longer time. So comparing the wall in A, which arrangement is more effective in reducing the rate of heat passing through the wall? Of course, the arrangement the second arrangement. I can say the arrangement with a layer of air, okay? Now, C. Count the thickness of brick that will have the same insulating power as a layer of air 10 centimeter thick. This one, be careful, it hasn't come out in the exam. So how do you compare? You want to compare, you must have the same difference in temperature, understand? And you have to have the same area, okay? Now, so that's how you compare. And you must have the same rate of heat flow, okay? So to find out how thick you need a layer of brick compared to a layer of air so that the heat flow, rate of heat flow is the same. So you must maintain the same temperature to be fair, okay? So these are the things you have to maintain. Okay, so you want to find this. Exam, you have to write, you don't need to write this, I can write the formula straight away. So you K brick A delta theta over thickness of brick 0.10 meter. Okay. You K air A delta theta thickness of air. Now this one cancels out. So you put inside. Oh, sorry. They want air. They give you air. They want brick. Okay. So a layer of brick. Okay. Now you'll find that the layer of brick 3 meter thick. That means to say 10 centimeter of air is as good insulator as 3 meter of brick. Okay. Okay. We are only considering conduction. we didn't consider convection. Okay, so they ask you to explain why in real situation the layer of air is not as effective and determined by calculation in C. Now this is because air also conduct heat by convection. Brick cannot, because conduction require motion of the molecules. Okay, brick cannot, the molecule cannot move. Unless the airspace filled in with plastic styrofoam with air pockets. Okay, so unless you fill the airspace with styrofoam with air pockets, you know why? Because when the air is trapped in air pockets, the air molecule got not much space to move. So this cut down heat loss by convection. Okay. So if you put like that, then air will be very effective as an insulator. Okay. So to answer a question, look at the marks first. So you can say air can conduct heat through convection as well. Okay. Now air trapped in air pockets in styrofoam. Okay. You can air molecules put in. Trapped in air pockets in styrofoam. Okay. Has little space to move. So heat transfer by convection is greatly reduced. Like I say, when answer essay question, look at the marks. If you don't look at the marks, you can never do well in explanation, even in exam. Look at the marks. Okay? Always look at the marks, even for calculation. For example, calculation there put 5 marks. And somehow or other, your calculation is 2 lines. Use some common sense, okay? There's something wrong with your answer. Understand? Usually the answer given STPM are written by very qualified professors. So the answer is the shortest one. Okay? So if you think your answer is shorter than that, you better check. If you are very, very sure, then okay. Understand now? Explanation, you cannot argue. Their explanation is also the shortest. Okay. So make sure you answer more than the mark. Don't be less than the mark. Okay. If you do that, you are going to do at least don't do smart carelessly. Okay. Now, okay. This is a very good question for revision. Look through this again before the exam. Now, okay. Number 8. A polystyrene box is used to keep drinks. Now, a cubic box of size 0.3. So 0.3, 0.3, 0.3, and 2 centimeter thick. is filled with at 0 degrees Celsius, the surrounding temperature 30 degrees Celsius. Find the power transfer through the box, assuming that heat transfer from each wall of the cube are the same. You are given thermal conductivity of polystyrene. And specific latent heat. Now, first of all, be very careful. Not the whole wall will conduct heat, because heat cannot go. For example, these surfaces, you got the wall here. The heat is not going to go through the wall, where the wall is this thick, understand? So the effective area is this area. Every side is the same. You understand or not? No, nobody understood. Because this is the wall. This is polystyrene wall, it goes this side as well. And then this wall also go this side. Okay? And then this wall go this side. So this wall also go this side. And so these are the wall. This one, the heat cannot go through. And this one go this side. So this side also, this is the effective area. Because the heat cannot go through here. This is so thick. So it can go through here, okay? Okay? Now, so the effective area a cube got 6 sides. Okay. So this area, now the effective area here is here's 2 centimeter, 2 centimeter. So each side will be 0.30 minus 0.04. Okay. So that is times 6 times. This is 0.30 minus 2 centimeter, 2 centimeter. Okay, so this is the area. And you got 0.406 meters square. So the rate of heat flow. Now the thickness of the wall, of course, is 2 centimeter, which is 0.020. So here is Ka. Now outside temperature minus inside over D. Okay? And this will give you 6.11. Okay. Okay or not? Yeah. Some schools are having some exam. That's why there are quite a number absent. Now, mass of ice melted. Now, one day the heat will be so much. 24 hours. 24 hours times so many seconds, it will ML. Now you know this, you find this, and you get this. Okay. Now, so that's it. Like I say, any question, do ask. Okay. Nine. This one watch out, also never come out before. This one, I think came out already, okay? But watch out, okay? This one came out objective. I cannot lie to you, got all the material now. So, hold on for a short while. Okay, now, okay. Now, point figure show a light bar XY of non-uniform cross section. One end X is capped at 100 and the other end is 0. Describe and explain how the temperature varies from X to Y in the steady state. Draw a graph to explain your answer. So now, here's the graph. So when you come over here, the cross-sectional area is going to reduce. So this explanation of the graph will be this. Now, this is the gradient of the graph. Okay? This one, I put anything because you don't know what in what unit. So all you know is this 100. And this is a constant because the bar is slack. So just say this is a constant. Write in words. K also constant because K only changes when the change in temperature is huge. Okay. So this is what you get. This is constant, this constant. So your d theta per dt, dl will be like that. Now this is a constant. Exam no need to write this, just write like that, okay? Understand? Because this constant, the theta per dl is inversely proportional to A. So when the A decreases, the d theta per dl increases. Now remember this is a negative gradient, okay? So at first the gradient also negative. Later it become more and more negative until go to 0. So this is your graph. Okay.
Sir,
Yes.
question number 8, what the area 1 to minus 0.04?
I told you this one is 2 centimeter. This 2 centimeter. You can, the heat cannot go through this area because this one goes all the way back here. So how can you expect the heat to come from here? It cannot practically go through this part because you talk about this area. This area is so thick. So from this side, the heat cannot go through this. Understand or not? So this 2 centimeter, 2 centimeter. So here is 30 centimeter. So this one, the effective area is 30 minus 4. Understand?
Okay.
But sir, just find for the land only, because we don't times together to get the area.
What are you talking about?
When
I got
we
6 sides.
Yeah, but when we minus 0.3 minus 0.04, we just get the length only. Area is the times of.
This square, sorry, right, wrongly.
Okay, okay.
Okay. Okay, it's good you ask. At least I can correct the mistake. That's why I always want you to ask. Okay, now number 10, I'm sure there's no problem. Now, let's finish it. Number 10, 11, any problem? If no problem, I'm going to skip it. Anybody cannot do number 10? If everybody can do, then I'm going to skip it to save time. Cannot do, raise your hand. Okay, number 11. Okay, okay, I won't do, okay. Okay, sure, okay. Then we go to the last part. Then number 10, 11, I don't consider difficult, but if you cannot do, raise your hand now. Nobody, okay, good. It's not that I'm lazy, okay, if you can do, then no point wasting time. I know the question is not very tough. So let's see the last one. Last one usually is quite easy. So the calculation part, the difficult one, they have taken it out. Okay, so I'm not going to teach you that one. Now, so we do it 4, 5, and 6, 7. Okay, these are nothing much. So number 4. Now, actually it's sitting on cloth in the locker room whose dark walls are at the temperature of 15 degrees. So temperature 273 plus 50, 288. Okay. Estimate rate of heat loss by radiation assuming the skin temperature is 34. Okay, so this 307. Now, E is 0.70, just nothing. Just use the formula, that's all. So E sigma A T24 minus T14. Okay. So that's what you get. Now, if you all this nothing. Number 5. Have I given you the answer? Yes, huh? Yes, huh? Yes or no?
Yes.
Okay, number 5 can do. Can do. I also skip it. Just using formula, that's all. But I cannot do. Raise your hand now. Okay, good. Number 6 I will do because there are some assumptions there. Now, unlike tin wall, copper tube of diameter 2 centimeter carries water, the temperature of, that means the different temperature is 40 K. Okay. Estimate the power loss if the temperature surrounding is 300 K. That means the outside, inside the tube is 340 K. Okay. So, state 2 important assumptions you have made. Now, this is a copper pipe. Copper pipe here, no need to say here is connected, so we don't bother. So effective surface is actually the surface area, which is 2 pi RL. Okay. They want per unit length. Okay. Now this 2R, so it's pi dl. So dq per dt is EA sigma T24 minus T14. Okay. So this E pi dl sigma T24 minus T14. So they want the rate of heat per unit length. So this is this. Okay. Now you don't know this one. So the first assumption you make is that we'll find that the copper pipe acts as a black body. So assumption. So the first one. Okay. Number two, all the heat released by the copper pipe is absorbed by the surrounding only. So these are two assumptions made. So with that, this becomes 1. And you know all the rest. Fine. 22 watt per meter. Okay. Now with that, we finish the syllabus.